Welcome to EDU World Space.
We want to find the escape velocity for an object that's on Mars and then one that's on Jupiter. So we saw earlier in the chapter that the escape velocity for any object on any planet is just the square root of 2gm over r, where m here is the mass of the planet and r is the radius of the planet. So part A, we're doing Mars. So I've just gone ahead and looked up those values in the appendix. So we have the mass of Mars and the radius of Mars. So all we need to do is just directly plug those into the equation. And when we do that, we find that the escape velocity on Mars should be 5.02 times 10 to the third meters per second. So about 5 kilometers a second, pretty fast. And then on Jupiter, 1.12 times 10 to the fourth meters per second. So even faster here. So its radius is a little bit bigger, which makes it slower, but then its mass is much bigger. So there are two escape velocities. And then they ask us, why does the escape velocity not depend on the mass of the object at all? So we can kind of intuitively answer this. We know that um, just like with gravitational force, the larger the force is on the object, which will always happen if an object has more mass, but then its acceleration will be less proportionately because that also depends on the mass of the object. But we can do this a little bit more analytically here too. So what we're actually doing to find this escape velocity is just saying that the gravitational potential of the object has to be overcome by the kinetic energy of the object. And so when we write down these two terms, the gravitational potential for an object, negative g m, the mass of the planet, and then little m, the mass of the object, over r, needs to equal 1/2 mass of the object, it's little m, times its velocity squared. And so both of these depend directly on little m, and so this will actually cancel out in this equation when we're solving for the velocity. So the larger the m, the more gravitational potential it needs to overcome, but the more kinetic energy it'll have at a given velocity. So they just end up canceling each other out.